Breaking news from Texas and Florida's Space Coast. It's January 22, 2026, and the countdown to humanity's next giant leap is underway. Two titans, SpaceX and NASA, are pushing the boundaries of space exploration. In Texas, SpaceX readies Starship for its 12th test flight, a crucial step toward Mars. Meanwhile, NASA's Space Launch System stands ready at Kennedy Space Center to send Artemis 2 astronauts around the moon, the farthest humans have traveled in over 50 years. These efforts mark a new space race, not just between nations but between bold, risk-taking innovation and methodical safety-first tradition. SpaceX aims for rapid, reusable flights. NASA relies on proven government-backed reliability. Both are racing to the moon, but their paths couldn't be more different. Tonight we'll go behind the scenes at Starbase and meet the Artemis 2 crew, exploring the technology and ambition driving this new era. Buckle up. History is unfolding before our eyes. At Starbase, Texas, the future is being built, one Starship at a time. All eyes are on Starship Flight 12, a mission to prove rapid reusability and reliability. SpaceX must show Starship can launch, land, and relaunch quickly, key for Mars and for NASA's lunar ambitions. The Super Heavy booster and Starship upper stage are stacked and undergoing final checks, with upgraded systems ready for the immense power of 33 Raptor engines. NASA's human landing system will be a Starship variant, so every test is vital for future moon landings. Flight 12 is a critical data point. Success builds confidence, while setbacks drive rapid improvement. SpaceX's iterative approach, test, learn, repeat, sets it apart, gathering data and refining design with every flight. Each mission pushes the envelope, from thermal tiles to hot staging maneuvers. Starship Flight 12 isn't just a test, it's a leap toward the moon and Mars. Before Starship ever flies, its design is pushed to the limit on the ground. SpaceX uses test tanks, practice dummies, to validate structural strength and new manufacturing techniques. These tanks are filled with super-cold liquid nitrogen, simulating the stresses of launch. Engineers pressurize them to failure, learning exactly where to reinforce the real rockets. Every burst tank is a lesson, making future Starships lighter and stronger. These tests directly shape the human landing system for NASA's lunar missions. Cryo-proof tests are a final checkpoint before any flight, ensuring welds and valves can handle launch conditions. It's all about testing as you fly, building confidence, one ground test at a time. This relentless process is the backbone of SpaceX's rapid progress. Starbase's towering Mechazilla isn't just a launch platform, it's a machine for rapid rocket turnaround. Its giant chopstick arms are designed to catch returning boosters, eliminating landing legs and speeding up reusability. Recent upgrades to the tower and static fire stands are all about launching more often, with less downtime. A second static fire stand allows parallel testing and prepping, just like a high-volume factory. For Artemis, SpaceX must launch multiple Starships in quick succession, one as a lander, others as tankers for orbital refueling. These infrastructure upgrades are essential for making that possible. The goal: launch, refuel, and land on the moon with unprecedented speed. The groundwork for a lunar fleet is being laid right now. Near the launch pad, SpaceX's new Gigafactory, Gigabay, is rising, built for mass production of Starships. The shift is from hand-built rockets to an assembly line process, like cars, enabling hundreds of Starships for Mars and the Moon. Automation and streamlined assembly will boost output and quality, with everything from raw materials to final assembly under one roof. New hardware rolls out constantly, supporting both Mars Dreams and NASA's Artemis missions. Multiple tanker flights will be needed for each lunar landing, demanding a large, reusable fleet. The Gigafactory is the key to making that fleet a reality. SpaceX is redefining rockets as transportation hardware, not bespoke machines. This is the industrial base for a multiplanetary future. While Starships take shape in Texas, history is being made on Florida's Space Coast with Artemis 2. This mission will send 4 astronauts around the moon, the first humans to do so since Apollo 17 in 1972. Artemis 2 is a flyby, not a landing, but it's a crucial test of the SLS rocket and Orion spacecraft. The mission will prove Orion's life support, navigation, and heat shield on a 10-day deep space journey. It's the first step toward landing the first woman and person of color on the moon. Artemis. 2 marks America's return to deep space, building on Apollo's legacy with new technology. The goal, a sustainable human presence on and around the moon, paving the way for Mars. Success here opens the door to a new era of exploration. Artemis 2's hardware blends cutting-edge tech with proven heritage. The Space Launch System is NASA's most powerful rocket ever, using shuttle-era engines and boosters for reliability. Atop SLS sits Orion, a deep space capsule with advanced life support, avionics, and a robust launch abort system. Orion's massive heat shield must withstand the intense re-entry from lunar distance. Safety is paramount. Redundant systems and a rigorously tested abort rocket protect the crew. SLS is expendable and costly, while Orion is partially reusable, contrasting with SpaceX's fully reusable vision. NASA's approach is traditional, prioritizing safety and reliability for crewed deep space missions. Different philosophies, but both aim to bring astronauts home safely. Artemis 2's crew embodies a new era of exploration. Commander Reed Wiseman, a veteran Navy pilot and ISS astronaut, leads the mission. Pilot Victor Glover, the first person of color to fly to the moon, brings recent Crew Dragon experience. Mission specialist Christina Koch, record holder for the longest female spaceflight, will be the first woman to fly to the moon. Canadian astronaut Jeremy Hansen, a former fighter pilot, represents international partnership and Canada's contribution to lunar exploration. Each astronaut brings unique skills, leadership, piloting, engineering, and global collaboration. Their journey inspires a new generation to reach for the stars. Artemis 2 is about people as much as technology. NASA's Artemis and SpaceX's Starship are a modern tortoise and hare race to the moon. NASA, the tortoise, moves methodically, prioritizing safety, reliability, and careful planning with the SLS and Orion. This approach is slow and costly, but designed for crew safety from the start. SpaceX, the hare, races ahead with rapid iteration, embracing risk and learning from failure to innovate quickly. Starship's goal, full reusability, and dramatically lower launch costs. SLS launches cost billions. Starship aims for millions per flight. NASA builds a flagship system. SpaceX builds mass transportation. Now, the two paths converge. NASA's SLS gets astronauts to lunar orbit, while SpaceX's Starship HLS lands them on the moon. It's a hybrid strategy, leveraging the strengths of both. The future of lunar exploration is a blend of tradition and disruption. Living on the moon means surviving long, dark nights. Solar power isn't enough. NASA is developing small portable nuclear reactors to provide continuous power for lunar outposts. These fission systems, about the size of a fridge, could power habitats, life support, and science experiments. Reliable power enables resource extraction, like mining water ice for drinking, growing food, or making rocket fuel. Nuclear reactors make 24/7 operations possible, a game changer for sustainability. Technologies tested on the moon will be vital for future Mars missions. The moon is the perfect proving ground for building self-sufficient infrastructure beyond Earth. Power is the key to a permanent human presence. The stakes for returning to the moon are enormous: scientific, economic, and geopolitical. China and others are racing to establish a lunar presence, making leadership in space more crucial than ever. Success for Artemis and Starship will cement American leadership and inspire global cooperation. Lunar missions will drive innovation, open new industries, and teach us how to live sustainably on the moon and Earth. Building a lunar base means mastering resource management, recycling, and survival in extreme environments. These lessons will help us reach Mars and beyond. The moon is our next frontier, a stepping stone to the stars. The story of Artemis and Starship is just beginning, and our future is written across the cosmos.